All right. So I just attended a session that was using custom GPTs as a preparation co-planner, and so it was kind of throwing out different scenarios that could be facing municipal staff, and it helps you kind of run through the different scenarios. And so I've been working on something slightly different because I'm a city council person. So I'm obsessed with the idea of like how do we make sure our policies are as good as they can be. And so traditionally, what that meant was a topic arises, or it's something that I've seen other communities do, and then we look at what's worked and what's not worked elsewhere. It's not always right sized for our community because there's so many variables at play. However, when I read the Google co-scientist paper, it really kind of sparked this idea in my head that if researchers, medical researchers, are using this co-scientist approach, which is assembling a team of agents to create a flywheel of analysis, like why couldn't we apply that to local policy making? And so I'm in the middle of this, and so I was intending to share this at some point when it was more polished. But the further I get into it, I realize it's just there's always going to be something else to work on. So just to kind of share where I'm at in this and what it looks like, we'll just go through this right now. So this was an older version of the program, and nonetheless, you can still see what's going on here. So this just AI powered multi-agent system for local government policy analysis. And then there was a few different options you could choose from. In this case, I selected option 4. This is the most involved and robust process that it runs. And then there was some attempt to add local contextual information, and you will see gathering local context down here. This was manual entry, and I had run this a bunch of times, and I don't know if I actually filled out all of the answers for this one. The idea, though, is that not only are we doing policy analysis, but it's going to be for our community. So one of the aspects that I'm actually working on right now is building an agent to go out and capture the local context for a community. So whether this ends up being a one-off or something that users can sign up and use, I wanted to create an agent that once the user signs up, we verify that you have a government ID, or I'm sorry, government email. Once we confirm that, then we go ahead and we search through our census information as well as some news articles just to get updated information. And so initially this was leaning on APIs, and like a lot of other people in this space, you're exploring MCPs, which is a model context protocol that was released from Anthropic at the end of last year. I still trying to wrap my head completely around its capabilities and shortcomings, but the way I'm thinking about it is you're creating an entity that has a relationship with the API, no matter how it changes. And so something I'd read online is, imagine you're at a warehouse and you have boxes that you take off the shelf, and then you stack those up and they ultimately go in the back of a semi truck. We're not working with the semi truck. We're not working with reorganizing the warehouse. What we're doing is we're just concerned about how we're taking the boxes, organizing them, and shoving them in the back of the truck for delivery. And so I can link more explanation on this and how it allows for different types of communication channels. It's not just stuck in HTTPS. So again, that's getting a little bit too jargony and technical. But right now we've gotten the census MPC to work, and it'll go out and it'll grab all this really good information that's much better than what these kind of just mocked up placeholder fields were demonstrating. I'm still working on the of all things, the Brave Search one, which is pre-built. I'm having issues integrating right now, but nonetheless, so as this program runs, you'll see, okay, it's like running through the tasks here, and then once it goes and it captures the context and the topic, then it starts a policy tournament. And this is what's super cool and fascinating that the co-scientist paper brought about. Again, I'll share that paper in the link so you can see their diagrams. It's really helpful for visualizing this and understanding it. And if you think this is slow, this version of it was just taking policy IDs. So each policy on the back end that it's going and it's capturing or creating, it assigns an ID, and it was just bouncing those IDs back and forth. And so, though it would create something compelling, which is kind of the story with AI right now, these LLMs, generative AI is that it's good, it works, it's really compelling, and then if you don't do evals on it or you don't check its work, you could be lulled into believing whatever it's outputting. And so, what we're seeing here is something that, okay, cool, round one, round two, round three, and then a winner will emerge, and then it'll go into an eval process. So it looks like we're getting through three into four. When I made the adjustment to actually evaluate this based on the full body of the policy, it took much longer. And as you can imagine, that means costs did go up. So initially, when this would run, I think it was costing me around 20 cents in API credits. And after I did this, I've only run it once on the new deployment of it, where it's comparing all of the policy body, subject, the entire body of the policy recommendation. I ran that, and it was over $1. And so not only for cost savings, but also the amount of time that it took. I mean, I think I had to run out to get groceries or something, so I clicked it to run. I don't actually know how long it took, but I'm quite certain it was over 20 minutes. And then so you'll see here in this end of first tournament round, it comes up with an ELO score. This is a system that inspired the Google co-scientist paper, and I believe this originated in trying to project out outcomes of chess matches. So now it's going into the evolve the policy topics. So it was looking at some of them that won, some of them didn't won, and then it's going to reconsider them and evolve them and then run the tournament ranking again. And so that kind of gives you an idea of what the Google co-scientist project was all about. Was it's you're working with a human in the loop. The human in the loop kind of kicks off the process. Then you have like a research agent, and then that goes, it finds everything. Then you have a judging agent that's part of the tournament rounds. And then there's additional components that the co-scientist paper built in that wasn't so much about doing the hard research on the front end. It was more so about checking for accuracy and quality on the back end with metadata. And so what we're going to see is in the database world, we've largely configured these to always be human centered. What we're seeing now is that we're going AI centered or agent centered design as well. And then when you merge those things into one database, you're going to need your standard columns, right? Date created, maybe created by, what type of file it is. You're going to have all those standard fields, but then you're also going to have a column that's going to include embeddings. And so embeddings are the language of LLMs. And when they're stored in a vector database, you could basically what's happening when you send a question to an AI is it's going through all of its embeddings and it's looking for ones that are grouped together. And so one of the agents that the co-scientist paper deployed, I think it was a proximity agent is what they called it. And it's basically double checking that when it's going and it's querying its vector database and it's finding similar embeddings, that it's checking for those proximities. And again, this is not my area of expertise, but I imagine that if the proximity agent found something that was outside of a certain threshold, it would say, okay, we might have a gap in our database. We don't have enough supporting embeds to actually answer that really accurately. And that's going to be a critical component of making sure that when humans do involve these agent systems, that we're not only checking the logs, but that we have a quick way to check, were the embeddings in the vector database close together, or did this thing have to reach outside of a normal bubble to grab something to give back to the user? And if that's the case, we need to throw up a flag and say, hey, we need to just dive into this section a little bit deeper. So now at this point in the video, you're seeing it's going through another round of tournament. And let's just click ahead a little bit here. Okay, no, sorry, here we go. This is now a new set of rankings, and then it's going into its third generation. It's evolving the policy topics once again. It'll rank them again, and then it'll come up with a final report. And so I'm going to let that run a little bit in the background to show you what kind of like really blew my mind, right? So this in and of itself, for somebody like me that's not a coder per se, but maybe I am a little bit now, all of that was interesting and it looks cool, but it's not that much, right? For the amount of time that it ran and the report that it generates, it was kind of like a 1 or 2 page report. And I just was like, well, that seemed to be a lot for a little. And then I opened up the logs. So what OpenAI did is a few weeks ago, maybe it was a month ago now, they released their agent SDK. And as part of that, there's a new API that they released called the Responses API. Now, this is very powerful because it created logs. And up until now, using OpenAI alone, you weren't able to really see behind the scenes what was actually transpiring. And this is critical, especially for sensitive industries such as mine and local government. And so, what then happens is, you create these logs and you create these traces. And so you can go in here and you can see what process was running and then what it did. So let's see what this one says. All right. Instructions. You are a policy judge given the list of evaluated policy proposals in a JSON format. Review and select the best the best proposal based on feasibility and impact. And so it goes and it shows the input, and then the output for it. So this is just one call out of, I honestly, I still don't even know when I trigger this workflow, how many API calls actually happen. This one, let's see, I think this one was a failed API call because it timed out. This is going to be another consideration we have to make, is making sure that we build into our program the ability to either pause or to limit the size of the request. And logs over here, we can see, let's go. We got policy query. You can see here, plan of focused research strategy for a policy topic. It runs through this plan here. It goes, and this is the user input, and this is the output. So, okay, now we're starting to see things that add context, and in my opinion, can start filling out a more robust database of policies. So again, going back, you can see, let's just judge by the time. This is 30th, so let's stick on the 28th, 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 28th. Okay. So it looks like 1, 2, 3, 4, 5 logs from the 28th. 25th, it looks like I did a bunch of work here. Now if we go over to my billing, and this is always fun to watch, you click the go button and you just see your credits disappear. Usage, I think we'll have to go back a month. Okay, excuse me. Last 30 days. Okay, we'll see here, 24th, 25th. So this is probably one of my late night projects I was working on. But this is what it looks like over here. So there's just a variety of considerations to make here. OpenAI SDK is amazing, and it allowed me to go in, clone the repository. Let's see, where is this running? Where do I have this running? Oh, wait, I'm sorry. This was a recording. So as you can see, it's still going here. Okay, so creating final policy report. And then if we just go, okay, actually I should back that up because this was probably the most gratifying thing once I got the spans to save. So what's happening here is the information that I was just displaying over on the Google Logs page. All of this I want. So what I'm trying to create is a database of policy. And so I want to go out and capture existing real world policy that's being deployed in local governments, not only for comparison, but also analysis. Beyond that, running this process over and over again, we're obviously generating a bunch of policy summaries, or maybe it's full-blown policies when we get to the finish line here. But I don't want to keep running these LLMs over and over again because it's costly, it burns up energy, and there's really no need for it. So what's great about the OpenAI SDK is inside of there's a function you can use that basically at the end, what you just saw, that visualization with the code running to create these spans, was it not only will it save in OpenAI's interface, but I have it forked over to a Supabase where I'm capturing all of this content that's being generated. The idea here is that if there's somebody using it, they can not only enter their local information. So say for me, Elgin, Illinois, my census MCP is going to go out and it's going to grab all of the relevant information for you as a sitting elected official. Then it's going to go do a Brave search. It's going to get local news and try to capture what's pressing in the moment. Then it's going to run through your policy topic. It's going to do the tournament. It's going to do the evolution. It's going to shoot out your final report. But then if you want to dig into the details of like what happened on the back end, we're going to have all of this nested in a nice, easy to use interface. That's the plan. It's obviously, like I said, I'm not a experienced coder, so getting this to work has been a little bit of a challenge. I think I've got a screenshot. Maybe I do somewhere, yeah, over here. So this is, what I do is I use Miro. I take screenshots. I can do call outs here, and then I share it back to whatever LLM I'm using. Mostly it's been Claude 3.7. And I don't have screenshots of all of the workflow, but something that I thought was important is to have a control room to see, how many tokens are being used, which agents are using how many tokens, etc. And I think this is going to be important for the end user. And so what you're seeing here, this is just a Streamlit interface. Again, to my limited understanding, I believe this is meant for use with Python projects, which the OpenAI SDK points us in that direction. So yeah, I will share this as soon as it's ready to go, and I want other users to use it, and I'll load up my credits, and you can just blast through them. But additional considerations to make is the OpenAI SDK. Some of the really hardcore developers have called out this really doesn't enable us to do anything we couldn't do already. That is true, but the analogy that popped into my head was kind of like the assembly line. Yes, there was various car manufacturers that could make cars from hand, and you're talking about manually fabricating the fenders, manually fabricating your brake systems, etc. And I think most people know Henry Ford created the assembly line, where there were certain portions of the warehouse that were focused on a specific component. And I think what we're seeing here is OpenAI is creating kind of the assembly line for these agent systems. And in doing so, they created this new agent SDK. Now, in the interim of this SDK being released, OpenAI adopted MCP protocol, the Model Context Protocol from Anthropic. And so that's really exciting because what we're seeing is from these mega companies who have raised record amounts of money is that they're more concerned about speed and the ecosystem than necessarily having proprietary claims on everything that comes out of it. That's good for practitioners because we don't want to be locked in. And I have that concern as a council member because we're currently locked in with some vendors that I don't want to be locked in with. And I think what we're going to see that's going to be critically important is that all of us who run agencies, we have multiple different vendors that we contract with, and they all handle our data. What is important to us, maybe not so much breaking free from that vendor, but is ensuring that they have a process in place to connect our data. It's going to be inexcusable very soon to be not offering your client, especially public sector clients, the ability to connect their data in meaningful ways. And if they don't react fast enough, I assume there's going to be folks like myself who figure out, well, we've got this public facing data. It's scattered all over the place. Let's just make MCPs and we'll create agents and we'll connect it all together. So considerations is vendor lock-in. Another consideration is OpenAI. And again, this is a little bit beyond my comprehension, but I get the gist of it, is they do allow you to plug other models into their framework. So you don't have to just use ChatGPT 4.0 or any of their other offerings. You can use other models. And what we saw recently, again, in between the time I'm making this and the time the Agent SDK came out, is that Google released 2.5. And to be completely honest, I've only played with it for a little bit. Been really busy coming out of campaign season, trying to get back to this project and a few other projects I've got spinning. But one of the next steps is once I get all of the kinks ironed out of this and it can actually function with a usable interface, I'm going to plug in Google, not only to evaluate the results and if there's one that's better than another, but to also limit costs. Because right now the 2.5 API is free to use in the research version. And that's what it was meant for. It's meant for people like us to experiment with and build with without incurring a bunch of costs. So yes, this was my first expedition into orchestrating agents. I had done so in other projects, but I think that would just be called prompt chaining. even though I could fire off one button click and that would queue, say, 5 different models that were using anything between ChatGPT 4 and 3.5. This was, I think, 2023 when I was doing this, so the model availability wasn't where it is today. And that at that time, I didn't even hear the term prompt chaining. I was just calling it like cascading because on my visual interface, I was using Coda. That's what it looked like. You would just kind of put in your prompt, you would fire it off, and then it would cascade down from one field. Then the other field would look at the output from the previous field, and it would use that to inform its input and output. And then I tied like 9 of those together. This is different because it has the evaluation process, the evolution process, and all of that's happening without me having my hands on the controls. Ultimately, what we're creating here, if this was a full screenshot underneath the detailed metrics, you'd have a layout of the different agents. And so the control room is meant to be a place where you can see your agent configuration. And those configurations are going to have kind of your system prompt, any constraints that you place on it, temperature settings, things like that. But then also I want to have a drop down that picks a model for you. And we'll have like a model legend that highlights the strengths, weaknesses of individual models, right? Some of them are very good, but they cost a lot. Some of them are very good, but they're slow. And so every user is going to have different criteria that they want to see out of the agent performance. But in other cases, I'm imagining there's going to be these agent orchestrations where we're actually using different companies for different agents. And for example, say the policy generation agent, it needs a lot of context and token availability. So maybe that's a Google Gemini agent, because that's the strength of Google's ecosystem, is that they have big context windows and they're really good at needle in a haystack. So perhaps we deploy that also on the judge. Maybe for the initial policy comparison agent, we want to have the smartest. And so in that case, maybe it's going to end up being ChatGPT 4.5, or maybe it's going to be Claude's 3.7, or maybe it's going to be an open source model like DeepSeek, as long as it's running locally, because there's all of these different considerations from a technical standpoint, but we also have the ethical considerations when it comes to existing in a local government space. Do we really prioritize open source? If that's the case, we prioritize it so much that we restrict our teams to using only open source for testing and deployment, or do we allow our teams to experiment with the state-of-the-art labs and then take those experiments and convert them into programs that use open source? So I just wanted to kind of do a brain dump here, because I've been working on this behind closed doors for a while now, and I think it's time to just start sharing it and see what people think. And so again, I'm doing a video over video, and I don't think there's anything else in this initial video. I mean, I think, just showing some of the outputs are just so massive that I think without going through all of them, I'm assuming we can shorten that up. Okay. I did all this in Cursor. Okay, this is probably a good place to take a beat. So for those of you like me who are new to coding, Cursor has been awesome. It's enabled me to make basic web pages. Even my basic web page, where it's kind of like a landing page that has a form, like an interest form submission and a newsletter sign up, I was able to connect that to Coda, which is my operation center for most projects. And it's great because once I receive the inquiry, the form submission at Coda, I can do whatever I want on that back end to automate or prepare draft responses, all different kinds of things. But much like everything else in AI, this is a tool that with great power comes great responsibility. And you could probably see over here, anybody who's coder, they're probably like, what have you done? And I'm realizing as I go through this that, I don't know what I'm doing. And so I've run refinements on just my code base and how it's structured. I didn't enter this project with a strong foundation, and there's been a lot produced in terms of how do you set up your Cursor rules, your project rules, and that's where the expertise of being a software developer really enables a level up. And so that's the main takeaway here. If you're going to attempt to do something like this, put in the legwork to get a strong foundation, and that's doing your product specs, potential user journeys, things like that. There's a ton of resources that are from experts. Yeah, I'm just regurgitating things I've come across once or twice, and I've tried to throw those into a repo for myself for my next project, so that these issues I'm running into here don't exist. However, what this really is, you just go to Google and type in OpenAI Agent SDK. That's going to lead you over to GitHub. GitHub was an intimidating place for me. It still is to some extent. I still don't fully understand how to leverage it to the best ability. But once you get to that OpenAI Agent SDK, you just basically go and you copy that URL. And when you're in Cursor, you can, I think I've got a Cursor tab open somewhere. Where are you? Here. It's really like when you go and you close a folder. So in this case, you would just close the folder, and then it's going to ask you, do you want to open a new project? And you say either start from scratch or clone a repo. Just click clone a repo, and then you'll drop that URL right here, and it will go and it'll clone it, open all of the same information that was shared on their GitHub. And then all I did really was I shared the Google, let's see, I think I've still got it saved in here, the Google AI co-scientist paper. And what I did is over here in preferences, you can go to cursor settings, features, and you can add a new doc. And these are all the ones that I've added over my time in Cursor. And it will go and like index the information that's on that page. Some pages are better suited for that than others. But I just, called this paper out and I said, hey, this is a Google co-scientist paper. I'm a locally elected official. I want to leverage this agent SDK to build a policy evaluation tool, and that's what set the framework for this project. And then, I've spent too many hours already refining and iterating, excuse me, but that's how I got started. So I think I'm going to stop here. Appreciate you if you made it this far. We're 27 minutes into something that's recklessly technical, I would call it. I've burned API credits that I perhaps didn't need to. I initially wasn't capturing those traces and spans and logs in a separate database, but now we are, and we can redeploy those for our users in a static sense. We don't have to keep generating. We just have those saved, and then we can share those with elected officials and staff across the world. And so this is the project that I'm working on, where I just want to create kind of like a local government policy repository that not only was co-created with AI, but then uses AI to connect local officials with relevant policy topics and research techniques to ensure that all of the stuff that's happening at the local level is as good as it can be. Because we all know there's unintended consequences from basically everything we do at the local level, and there's a lot of time and energy that goes into minimizing the negative outcomes or impacts from those decisions. So again, thank you for your time, and I hope you found this valuable.